Hi friends, welcome to all. In this video we are going to see how to configure RIP version 2. Here we will use 3 routers, 1941, also 3 switches, 2960, also NG devices. We will rename our devices. This is S1 and this is R1. Here we have R2 and S2. This is R3 and S3. Here we can see the PCs, PC0, PC1, PC2, PC3, PC4 and PC5. Now we will add a serial interface for these routers. Coming to R1, we will put off this device and coming to this module, this is a 2-port serial high-speed WAN interface. We are going to add this interface here. Then coming to R2, put it off, add the module and then put it on. Coming to R3, right. Now we will connect these devices. Coming to connections, copper straight through. Here we are going to use a G0/0, 2G0/1, F0/1 to this PC0, F0/2 to PC1. So here we got one network. We will highlight that. Here is the network. This is network 1, and here we are going to use the network address 192.168.1.0/24. Here is our next network. Coming to R2, G0/0 to G0/1, F0/1 to PC2, F0/2 PC3. We are going to highlight this network. This is network 2, and here we are going to use 192.168.2.0 network address. Here is the third one, R3 G0/0 to G0/1, F0/1 to PC4, F0/2 to PC5. Here is our third network. Network 3, and here you are going to use the network address 192.168.3.0/24. Now we are going to connect these routers using serial cable from R3 serial 0/0/0 to R1 serial 0/0/0, then from R3 serial 0/0/1 to R2 serial 0/0/1. So here we got two more networks. Here is one. And here is the other. Here for this network, I mean the network between R1 and R3, we are going to use the network address 172.16.1.0/30. And for this network between R2 and R3, we are going to use the network address 172.16.1.4/30. Now we will set IP address for these PCs. First of all, we will come to network 1 and PC 0. Here we can see we will be using the network address 192.168.1.0. So here for this PC, we will give the IP address 192.168.1.10. Subnet mask, then the default gateway. So default gateway will be the IP address of this interface, that is G0/0 on this router R1. We did not set the IP address for this interface, we have to set that. Anyway, here we are going to set the first usable IP address from this network. That will be 192.168.1.1. Coming to PC1, desktop IP configuration 192.168.1.11, 192.168.1.1. Now we will come to PC2. Here we can see, here we have to use the network address 192.168.2.0. Coming to PC2, desktop IP configuration 192.168.2.10. Here is the subnet mask. Here we are going to use the default gateway as 2.1. Coming to PC3, desktop IP configuration. Here we are going to use 2.11. Subnet mask and the default gateway. Here is that. Coming to PC4. Here we can see we have to use the network address 192.168.3.0. Here we will give a 3.11. We'll give 3.10. Subnet mask default gateway 3.1. Coming to PC5. Here we will give 3.11. Subnet mask and the default gateway is here. Here we can see the IP address details of each PCs. PC0, PC1. Here is PC2 and PC3. And here we can see PC4 and PC5. Now we are going to verify each local networks. We are going to take this symbol PDU, and we are going to send a message from PC0 to PC1. Here we can see it's successful. Now we will send from PC2 to PC3. It's successful. And from PC4 to PC5, it's successful. Now we will configure the default gateway of each network. Here we can see each networks are connected to the interface G0/0 on the respective routers. Here we can see this network 1 is connected to G0/0 on this router R1. Network 2 is connected to the interface G0/0 on this router R2. And network 3 is connected to the interface G0/0 on this router R3. First of all, we will configure the router R1. CLI. Would you like to enter the initial configuration dialog? No. Enable configure terminal. First of all, we will set the host name here as R1. Now we will go to the interface G0/0 and here we will set the IP address 192.168.1.1. Then the subnet mask 255.255.255.0, and we will give a no-shut command so that this interface will become up. Here we can see that. So this IP address we given as default gateway for these devices PC0 and PC1. Even if we set IP address and the default gateway for this S1, here we will set the default gateway as the IP address of this interface. Now we will come to the router R2 CLI. Now enable configure terminal host name as R2. Now we will go to the interface G0/0 and here we will set the IP address 192.168.2.1. Then the subnet mask 255.255.255.0. No shut. Here we can see the link between R2 and S2 is up. Now we will come to R3 CLI. Nope. Enable configure terminal hostname as R3. We will go to the interface G0/0 and here we will set the IP address 192.168.3.1. the subnet mask 255.255.255.0. no shut. And here we can see the link between R3 and S3 is now up. Now we will ping each PCs to its default gateway. First of all, we will start from PC 0, command prompt, ping to 192.168.1.1. Here we can see we are getting the replay. We'll copy this command and coming to PC1 command prompt. Here we can see we are getting the replay. Now we will come to PC2. Here the default gateway is 2.1. we are getting the replay. Coming to PC3 2.1, we are getting the replay. Coming to PC4, gateway is 3.1, we are getting the replay. Coming to PC5, 3.1, we are getting the replay. Here for this router R1, for the interface G0/0, we used the IP address as 192.168.1.1. and for this interface, for this router R2 G0/0, here we used 2.1. and here for this router R3, for the interface G0/0, we used 3.1. Now we will configure the serial interface on each routers. Here we can see on this router R1 the serial interface serial 0/0/0, which is connecting to R3 interface serial 0/0/0. Here we have to use this network address 172.16.1.0. Here we are going to use 1.1 for this interface serial 0/0/0 on R1 and 1.2 on this interface serial 0/0/0 on this router R3. First of all, we will configure it on R1. We will go to the interface serial 0/0/0 and we will set the IP address 172.16.1.1. Also the subnet mask 255.255.255.252. we will give no shut command. We can see this link between R1 and R3 is still down because we have to give no shut command on the other end, on this interface serial 0/0/0 on R3. So we will do that configuration now. Coming to R3, enable configure terminal, we will go to the interface serial 0/0/0 and here we will set the IP address 172.16.1.2 and the subnet mask 255.255.255.252, and we will give an offset command here. Now we can see the link between R1 and R3 is up. So here on this router R1, for the interface serial 0/0/0, we used 172.16.1.1/30. Here it's a /24, and here on R3 for the interface serial 0/0/0, we used 172.16.1.2/30. Now we will verify by pinging from R1 to R3 and vice versa. Coming to R1, we will ping to 172.16.1.2, and here we can see success rate is 100%. Coming to R3, ping to 172.16.1.1, and here we can see success rate is 100%. Now we will configure this link, the link between R2 and R3. Here we can see the interface serial 0/0/1 on R2 and serial 0/0/1 on R3. And here we have to use the network address 172.16.1.4/30. So here we have two usable IP address, that is 1.5 and 1.6. So 1.5 we are going to assign for this interface serial 0/0/1 on R2, and 1.6 we are going to assign for the interface serial 0/0/1 on R3. Coming to the configuration on R2, enable configure terminal, and we will go to the interface serial 0/0/1, and here we are going to set the IP address 172.16.1.5. Then the subnet mask 255.255.255.252. No shutdown. Coming to the router R3, configure terminal interface serial 0/0/1, IP address 172.16.1.6. the subnet mask 255.255.255.252. We will give no shut command, and here we can see the link between R2 and R3 is now up. Now we will verify this using the ping command. Coming to R2, ping to 172.16.1.6. Here we can see success rate is 100%. And coming to R3, ping to 172.16.1.5, and here we can see success rate is 100%. Here on this router R2, for the interface serial 0/0/1, we used 172.16.1.5/30, and here it is /24. And here on R3, for the interface serial 0/0/1, we used 172.16.1.6/30. We will save the configurations on each routers. Copy running config, startup config. Coming to R2, copy running config, startup config, and coming to R3, copy running config, startup config. Now we will verify the routing table of each routers. Coming to R1, here we are going to give a show IP route, and here we can see the details. Two connected networks, here we can see. Coming to our topology, here we can see this router R1 is connected to the network 1, and this network, we will give this a name, network name as network 4, and this is network 5. So this R1 is directly connected to network 1 as well as network 4. Instead of this, better I will give this is network 4 and this is network 5. It's looking good. And when we observed the routing table of this router R1, this router R1 is unaware of these networks, that is network 2, network 3 and network 5. Now we will verify it on R2 by giving the show command, show IP route, and here also we can see two directly connected networks. Here we can see 172.16.1.4 network. Here we can see that it's a network 5. Also we can see 192.168.2.0. It's network 2. So here this R2 is aware of these two networks, network 2 and network 5, and unaware of these networks, network 1, network 3 and network 4. Now we will come to R3, show IP route, and here we can see total 3 directly connected networks. Here we can see 172.16.1.0 connected to serial 0/0/0/0, which is connecting to R1. Here we can see that network 4. Next is 172.16.1.4 directly connected to serial 0/0/1, which is connected to R2. Here we can see that network is network 5. Also here we can see 192.168.3.0 directly connected to G0/0, that is a network 3. So this router R3 is aware of 3 networks, network 3, 4 and 5, but it's unaware of the networks network 1 and network 2. Yes, so each router should be aware of all the networks. In this topology here we can see total 5 networks. So each router R1, R2 and R3 should be aware of all these 5 networks. But here these routers R1, R2, R3 are not aware of all these 5 networks. So now we are going to configure a dynamic routing protocol, that is RIP version 2 on all these routers, so that these routers are going to find the remote networks and update these new networks in the routing tables. Now we will configure RIP version 2 on each routers. First of all, we will configure on the router R1. Enable configure terminal. Here we are going to give router RIP, and here we are going to give the version. Here we can see 2. Here I am going to give do show IP route connected, so that here we can see the network address which is directly connected to this router R1, and we have to give the network here. Enable routing on an IP network. So network, here we can see the network address 172.16.1.0. So we will give that 172.16. It's a B class address, so that we can give here 0.0. Also we got one more network here. It's 192.168.1.0. 192.168.1.0, and also we are going to give no auto summary. Now we will configure it on the router R2. Enable configure terminal router RIP version 2. Also we will give no auto summary. Here we are going to give do show IP route connected. We can see two directly connected networks, so we are going to give that here. Network 172.16.0.0. also we have network 192.168.2.0. Now we will configure it on the router R3. Enable configure terminal router RIP version 2. Also we will give no auto summary. Do show IP route connected, and here we can see total 3 directly connected networks. We are going to give that here. Network 172.16.0.0. also we can see 172.16.1.4. anyway here we given for that in B class network address. Also we have network 192.168.3.0. also we are going to configure a passive interface on all these 3 routers, so that it will stop RIP updates from being propagated out of this interface G0/0 on each routers. First of all, we will do it on the router R1. Configure terminal router RIP passive interface G0/0. Copy running config, startup config. Coming to R2. Configure terminal router RIP passive interface G0/0. Copy running config, startup config. Coming to R3. Configure terminal router RIP passive interface G0/0. Copy running config, startup config. We will verify this RIP configuration on each routers. Coming to R1. Here we are going to give show IP protocols, and here we can see the details. Here the routing protocol enabled is RIP, sending updates every 30 seconds. Here we can see this RIP version is 2. Also we can see routing for networks 172.16.0.0, 192.168.1.0. Coming to R2. Show IP protocols, and here we can see the details. Coming to R3. Here we will verify using show running config. Here we can see router RIP version 2. Also we set passive interface G0/0, and we given the network command. Also no auto summary. Now we will verify the routing table of each routers. Coming to R1. Show IP route, and here we can see total 5 networks. Here in this router R1 we can see 2 connected and 3 remote networks which is linked with the help of the protocol RIP. Here we can see the character R. R is for RIP. We'll verify it on R2. Show IP route. Here also we can see tree route learned with the help of the protocol RIP. Coming to R3, show IP route. Here we can see 3 connected and 2 route learned with the help of RIP. Now we will try to ping different networks. We will ping from network 1 to network 2. Coming to PC0, command prompt. Here we will ping to this PC, that is a PC2, 192.168.2.10, and here we can see we are getting the replay. Also we will try to ping to network 3, PC4, ping 192.168.3.10, and here we can see we are getting the replay. So here in this topology we can try from any device to any other device, so it should succeed. Well, in this video we have seen how to configure a RIP version 2. Friends, if you have any doubt in configuring a RIP version 2, please comment below. Also, if you like my video, give a thumb and share with your friends. And if you like to get this type of videos in future, consider subscribing. Thank you.